Hey guys, as promised, here's kind of the more technical breakdown of this RealityKit application. So I'm going to walk through a few more things in detail. So we'll launch the application. Actually, I had it running already. So let me force quit and relaunch it. And so the first thing you see is that AR coach marking view. That actually is really nice because it has delegate methods to tell you kind of when it's showing, when it dismisses, and then once it dismisses, you can assume that it's found its kind of target or goal, and then you're safe to start adding your actual anchors and models. And so if you're unfamiliar with that, you get it for free in ARKit. You basically assign it a goal. And so my goal is to find a horizontal plane because that's where I want to put my paint models on. And then once it kind of achieves that goal, it dismisses itself and tells you, hey, I'm ready to start adding models. And so once I do that, or I should say in parallel, at the same time, I'm asynchronously loading the models, materials, and some HDR lights. So all that's happening with Combine framework, and I'm storing those in either variables or in a dictionary variable for the lighting, just because I want them cached and readily available. So kind of a lot's happening before the model animates up. And then let me force quit this again. And just pay attention to once it animates up, and then the UI kind of pops in at the bottom as soon as the model has appeared. So I thought that was important. So you're not seeing the UI right away. It waits for the model to animate up, then the UI appears. The other thing is this animation. So it looks pretty simplistic. You think, oh, it's a 3D rotation and a translation, but there's actually a lot more going on than that, because if you look at this is pinned to a plane anchor. So it moves as I move the camera, and once you animate it, see now it's pinned to a camera anchor. And so it actually is doing some quick, you can call it anchor hopping from one anchor to the other while it's animating. And then before it can hop anchors, it needs to kind of translate its transformation into the new coordinates or coordinate space. And so when I tap it, I quickly use a convenient method from Apple. I forget, I think it's in, I don't know what framework it's in, but it allows me to take the current coordinates of my entity and then translate it to kind of the new parent of that entity, that it's going to be the camera. And then once I've converted it, I quickly add it to the camera, and it's very seamless. You can see if I added another one and go over here, tap this one, I have that little selection indicator, so it doesn't matter kind of where it's at. It animates, really nice. So, it took quite a bit of work to get that the way I wanted it. That white disk is basically a selection indicator, tell you which one's currently selected, so you can change the color. When you get underneath here, also there's that text view. And so I first actually built that as 3D text, kind of naively. And so if you've ever seen basically the mesh, you generate a text mesh, and it's very simplistic. You can't really do different font sizings, and you can't do different weights and so forth because it's geometry. And so I wanted more control. So I built it first as a mesh, just because I wanted to prove that I could do it. And that became a pain in the ass too with some of the rotations and stuff, just because the text anchor is lower left, I believe, and not in the center. So, I expected it to be in the center like everything else. And so I was trying to position it properly, and then it wasn't. And once I figured out it was a lower left coordinate, then I got it. But then I started thinking about there has to be a better way to do this. So I'm actually using an image on that plane, so that it's technically it's a box, because a plane is only one-sided and the box is two-sided. And so if it was a plane, the material wouldn't be showing, so it's kind of a shallow box. But anyways, the material I'm generating quickly at runtime. And so I'm basically drawing those images really, really quickly using the low-level draw APIs, and that gives me more control over the text, and I can do different weights and different layouts and different colors, and then cast those images kind of into a dictionary. And then if I have the image, I just show it real quick, and so you can see it's very performant. You almost don't even know that it's happening, and it animates really well. And then on animations, like I'm hiding that plane, I'm hiding it when it's not showing. So as soon as it animates down, I get rid of that card, so it's not in the view. When it animates up, I get rid of that selection disk, so it's not being animated or casting a shadow. I'm being very conscientious about the entities and the hierarchies and children and so forth. The other thing I wanted to do is and let's just talk about this animation. So you see it scales, blurs, and then has the translation or from the, this translates in. That was not complicated, but it took more code because I'm using asymmetrical asymmetrical transitions. Basically, it's a different transition for the in and then the out, and then I'm using the whole any transition thing where you can kind of override more granular kind of the settings and the easing, and then I'm adding delays too because I didn't want stuff overlapping each other. So to get that animation took quite a bit. But this is the HDR lighting thing I was talking about. And so right now it's using kind of the default lighting from RealityKit, which kind of simulates your room. And my room is pretty dark. And so I built in these, which are basically different environmental maps or HDRIs. And so this one, you can see, I go there and that metallic effect, and this is a night scene, is really apparent. And I just thought that was cool to kind of simulate those. And so I'm just swapping out the environmental lighting map at runtime. And like I said, because I asynchronously loaded those, there's no jumping, as I change them. So it's not downloading a 5+ megabyte file every time I change this. They're kind of cached and it's very performant. And I just like the dynamic nature of it, and it changes the models. The other thing I went down the path on is, let me get out of this. One other thing. So when you're in here and you can't see me dragging, but if I try to drag this entity, I'm basically disabling the gesture recognizer, because I don't want people dragging these. I don't want people tapping on, and I'm tapping on this car over here to the right, but you can't see and nothing's happening. So I want it to be as secure as possible. So because you can drag this because it has that installed gestures on it, but once it's animated, you can't do that because I'm trying to keep everything as consistent as possible. So that was important. But this info view up here, so this actually took some consideration. It's a simple info view and the animation at the bottom, but at first I was like, okay, I want it to be a native SwiftUI view and I want that video. And then I went down the path of, well, SwiftUI only has kind of one video player and it has controls and I can't do inline and I can't do all this kind of fancy stuff. So then I went down with the UI view representable and video players, and I was like, this is like a lot of overhead. I went down image sequence. So if images, you usually can pass an array of images to like a UI image view and then animate it. So SwiftUI doesn't really have that. So I ended up using a WebView, which probably sounds crazy to people, but if you look at it, you really can't tell it's a WebView. I'm pretty proficient with web development, and so I've built this in a manner where nothing's flashing, there's no weirdness, everything's performant, it acts completely native. The video, you don't see anything weird with that. So yeah, this is a web view just to give me the kind of inline look that I wanted of that video. The only probably way you could tell it's web view if you push down on this text and you get that zoom. But other than that, I disabled the selection state with CSS and all that. So you really can't tell. The other thing I want to talk about is scroll reader. So if you look at, when I change these colors, you can see that the scroll view animates to the selected color, so you can quickly get back to the color you were at. So that was using scroll reader, and so that was kind of a new concept for me with SwiftUI. And it's also using the on change. So it's basically doing that like KVO type, like looking at the key and detecting the change. And so the key is basically the currently selected PTS color. And so once it changes, it then detects that change and it's an event. And so then it changes that. So using the scroll reader to do that. And then I had to do some stuff with the order of operations just to make sure that it did it properly. Then there's this little debug view. So I have like the show statistics, which is AR view's statistic view. Show the frame per second, the mesh counts. Then I have this show material sample. So this is where I was doing a lot of debugging of materials to figure out the right combination of roughness and metallic and clear coat and different maps. So this is kind of a debug view that I was playing with. Let me quit that because I didn't build a way to dismiss that. So I'll go back through here. The only other thing I wanted to say is after I got done building this, I wanted to make it as performant as possible. And so really understanding the like say scene understanding is a good example. So I'm leveraging a lot of that, right? There's a lot of things in there I didn't need. So like depth of field and person occlusion and face tracking, or I forget what the name it is. So those are all disabled because I don't actually need those in my application. And so, they make it much more performant. I kept on like the film grain because I felt that was important to make this look real. But I basically just went through all those properties and figured out what do I need, what don't I need, and then just kept an eye on the frames per second to make sure it was hitting that 60 frame per second mark that I wanted. And then also from a performance standpoint, just making sure that, like the whole, if you're familiar with 3D development, like this model is a low poly model. So I built it as a high resolution model, baked the normal map from that high resolution model, then exported it as a lower, so I decimated the geometry, made it low resolution, and then put that high resolution map on there. So I did that. I explored flattening all the entities into one, which is a performance gain. I'm not doing that here because it didn't serve my purpose, but you could flatten your entities. So right now this is separate entities. Basically swapping in and out entities from is enabled, when it's not visible or I'm not using it, I make sure is enabled is false. So it's not doing any unnecessary rendering. So just being really smart about the entities and the entity count and all that. And so this thing is, I'm going to run out of table space, but see, I've added all these and I'm not really seeing, too crazy performance drop. Trying to think. If you guys have any questions, just let me know. I'm happy to answer anything, and I might actually release the source code for this because it's not a project I intend on submitting. It's more of a learning project. So, I learned a ton, so I'll probably submit or upload this source code. But yeah, if you have any questions, please reach out. Thanks so much.